Hello everyone, welcome back to our channel. So I have decided that from starting today I'll go through the daily Leetcode challenges and we'll solve it together. So let's go to today's Leetcode challenge. Today's problem is palindrome linked list. So it's we are given a head and we need to traverse the linked list or however the way you want and return true if the linked list is in palindrome and false otherwise. Okay, so I think we all know what palindrome is. So it's a easy question, right? We are going to start solving this problem in incremental manner, so from easy to like more optimizing step by step. Okay, so let's go. And I think so I guess so what the first solution which comes to my mind is what if I convert this into an array palindrome, right? So that way it will become very easy for me to check, right? How? Because array and vectors I can directly address it by indexing. So right, so in that way the only thing it does is it increases the complexity by space complexity mainly by O of n, right? Because we are going to store n nodes in the some vector or anything, whichever container we decide to go, right? So let's go ahead. So suppose we have a vector and we can store the list node as well as the integer value, right? So what we'll do is, the good thing we can store easily, let's store the int values. Okay, so this is our list, let's call it L. Let's just store this list node pointer current equals to list node pointer current equals to head, while current, what we are going to do is L dot push back current value and will current equals to current next, right? Now we have all the values, for example 1 2 2 1 in the list vector, right? Now what we'll do is we'll just take the size. So what we'll do is we'll consider left pointer and right pointer, right? So we'll have left equals to 0 and right equals to that size minus 1. So L dot size minus 1, right? Now we'll just compare everything is equal or not. So 1 is equal to 1, if yes then good. 1 is equal to 2, 2 is equal to 2, yes, then go ahead, keep moving ahead till the time when L is greater than or equal to 0, right? If that's the situation, then we are good. Okay, if any time in between anything is not equal, then we're just going to return false. So let's see. So while left is less than or equal to right, okay, if L of left not equals to right, L of right, then we're just going to return false. Okay, and then left plus plus and right minus 1. Okay, more easy, we can do this way. Okay, and we'll just return true. Let's see, we'll try and submit it. Okay, so it's running fine. Okay, the more easy way, what I feel is, what I can reduce this code is what if I do left plus plus here and right minus here. So what it will do is it will check and it will just finish it, I guess. So this reduce the number of lines we need to write the code, right? So this looks fine, I guess. Okay, here we go. So there is another container that we can use is, right? So you all must have heard about the stack container, right? So we can also use stack over here, right? Let's do it some better the other way. We're still gonna need some of and time complexity, but that's fine. We are just exploring ways to do one problem can be solved into multiple ways, that we all know. We're just going to explore that way. Okay, so second thing is stack. So just stack and s, let's say stack is called s, and same as this, list node pointer current equals to head. Now while current, what we are just going to do is s dot push current value, current equals to current next, and right now we don't need to do anything. We'll just do is, well, this dot is empty, stack is empty, or we say t false. Let's just convert it to true, and then as the top, let's again do where current equals to head, and say current value. If that's the case, then current equals to current next, and s dot pop. Fine. So there is one more thing. If current, and then if we have current, then we'll have stack, so maybe we don't need to check this again, and we just current value, and then so we'll just check if our current reach to last, right, maybe to the null pointer, then yes, this is a palindrome, right? So we'll just return current equals to null pointer, right? Let's see if how this goes. I think it should work. Okay, let's see. It's okay, so it passed 3, so I think it should pass all the other cases. Yeah, so it passed with stack also. So we are now currently using O of n time complexity, right? How can we reduce this, right? To reduce our O of n space complexity, what we're going to do is we're going to use slow pointer fast pointer approach. So that's a very common approach in the linked list problems. Generally we use it to go to the middle element, right? Or like you must have done to find the cycle or something like that, right? So let's go ahead. So what we'll do is we'll just use that approach to reach to the middle element, or maybe in this case 1 2 2 1. So our slow pointer I want it to here, and what I'll do is I'll reverse the second part of the linked list, and then I'll compare this with this, right? We will moving forward, right? So yes, so what we'll do is let's store this. So list node pointer current is head. Okay, sorry, slow, we are going to use slow and fast, and this we have first. Okay, while, so how this work is, while fast and then fast next is not null pointer, right? So that fast can move next forward, right? So what we'll do is slow will move 1 step and fast will move 2 steps. So slow equals to slow next, and fast will become fast next. Alright, okay, here we go. So This will break when fast reaches the null pointer, which is here. Now what we'll do is we'll just reverse the second part of this. So slow is here, we just want to reverse our linked list, right? So what we'll do is reverse linked list. So this node pointer rev list, reverse list. Let's call a function. What we can do is we can use yesterday's code, so it's easy. A star here, because why not? Why to do same work twice? So what I'll get is reverse list, and I'll pass slow here. Now what I need to do is while reverse list, if reverse list value not equals to, okay, let's store, okay, head value and return false, and head will move to its next. Sorry, head equals to head next, and our reverse list will also move it to next. Reverse list will move reverse list next. Okay, now if that's done, then it should return true. I guess so this should work. I guess reverse linked list will work fine. Let's submit it. I think it should work fine. Yeah, it worked fine. Yeah, so yes, we are finally done with our today's problem of Leetcode. It was a easy problem, yes, it's fine. So to those who wants to understand the reverse the linked list approach, right? If any one of you is having problem in understanding, feel free to comment. I'll come up with the video to understand, like I'll try to make it as simple as possible so that you guys can understand easily. Yeah, so that's all for today. Thank you guys. Bye bye, have a good day.